Well, thank you for that intro. In the interest of time, I think there's probably more interest in the content than me, so we can talk later. But yes, I'm glad we're having this talk after lunch, so hopefully you're not super hungry or anything, but I like to use this metaphor of cooking because it really much is taking a lot of these sort of best practices, creating recipes out of it, templates, if you want to call it that. And yeah, if you're building an AI application, well, let's dive in. All right, so if you haven't heard, Microsoft is all about Copilot, and Copilot is, this kind of center of gravity of all of Microsoft's AI efforts, especially with OpenAI, for building products that are meant to assist in the human creation of either work tasks, creative tasks, and all that. So it's your everyday AI companion. We already see a lot of this. Actually, this was just announced, I think, last week, where whether it's in Word or the revamped version of Paint, to even the newest Surface products, Copilot is everywhere, and it's getting more and more adopted as a standard. One of my favorite sort of demos that came out was for Copilot in Excel. So one prior announcement that came before the Copilot announcements was Python being able to be run in Excel. And having a Copilot interface, in this case it's expressed as a chat interface, being able to do your sort of analysis over your data in a more hopefully friendly way, so you're not having to memorize formulas, VBA, whatever the tool of choice was back then. So yeah, now this is hopefully more natural. So natural question is, how do you build copilots, right? I think this is very much an interesting field that is emerging, and Microsoft is one of the voices in this, but as you all have seen and heard throughout the couple days, right, there's many different approaches for building a copilot. But before we go into this, right, let's just kind of take stock in the moment that we're in. Like, what is this burning moment in technology? Well, I think for many of us who have either been building in AI or you're a product leader or business leader, you might have seen or experienced that AI was always kind of hyped up or talked about, but it had a hard time graduating from the research lab, from just kind of experiments that your data scientists are doing in their Jupyter notebooks to actually manifesting itself in a real product. So that was back then. Well, what about now, right? I think we are now at this point where ChatGPT just exploded on the field. I think it's a very interesting story, right? OpenAI didn't intend to become a product company, but they kind of put it out there, put ChatGPT out there to just learn how people would use AI, and in so doing, they sort of launched this revolution, right? The revolution for building chatbots, or the revolution of the innovation of chatbots, and even just copilots. So the number one use case that we're hearing, that I'm sure you all are experiencing, is you want to be able to have that sort of ChatGPT-like experience on your own data. So how do you do that? Well, one of the opinions that we have is that you need more than just a model API. And it's actually kind of speaks to this new way of coding, new way of development, that, right, when you're building with large language models, they are, it's kind of unfamiliar, right? Maybe a lot of the developers in the room, they are very, very much attuned to writing code natively in their programming language of choice. But when you're interacting with large language models, with these foundation models, it's a little weird, right? You're talking in natural language. You're having to maybe go back to your, I don't know, high school days to figure out how do I speak coherently to an AI. And there's all these like other things or considerations you have to think about. Tokens, temperature, and just overall dealing with non-determinism, right? AIs, when you're building with AI, you're starting to delve into this area of a probabilistic outcome as opposed to a deterministic one. At the same time, right, if you're going to be interacting with OpenAI or any of these foundation model APIs, well, a huge benefit is that they've just made it super easy, right? You can just get your API key from OpenAI or Azure OpenAI and just run something very simply out of the box. But the challenge is that as you're building more complex applications, as you're building copilots, right, you're going to start hitting some real limits. And part of that is there's no memory, right? These large language models are effectively kind of like state machines that you send in your prompt to, you get a response back, but it doesn't by itself know anything about you or remember your past conversations. So we had a lot of talks today from a lot of the vector database companies and others looking to build this type of capability. We heard RAG mentioned many times over as a pattern, retrieval augmented generation, right? And that's really to help bring memory into your copilots. There's also this idea of this knowledge cutoff, right? Where these models are trained up to some point. They only have the training data, to 2021, and if you're trying to ask for factual questions beyond that, you won't be able to get it. And probably the trickiest thing is this idea of hallucination, right? The models can be very confident in giving a wrong response. And especially if you're going to be building any sort of copilot in a very regulated or sensitive industry or your use case, right? You don't want your model to be wrong, or you don't want your application to be wrong. So as a result, right, we believe, or that we actually experienced inside the office of the CTO that you need new tools, right? When you have foundation models that introduce new capabilities, right? GPT-3 to GPT-4 was this huge step function that when we had early access to that model, we for sure concluded that we needed to build common tools, common frameworks, so that everyone's not reinventing the same thing again and again. So imagine having experiences where you can talk with your AI or your chatbot infinitely, right? There's no sort of forgetting of who you are or what you talked about, right? A conversation that you had last year or 10 years ago, it should be able to remember you, just as we remember the people that we meet at this conference or the people that we talk to. Especially when you're starting to do long-running tasks, right? Multi-step, things that require multiple decisions or actions being taken, then you need to do more advanced orchestration for that to happen. So as such, whoops, go back. And actually, there's no sound coming, so I'll try one more time. So I'll actually let our CEO, CTO, talk a little bit more about what you need to build this future.
The Copilot stack, right? After all, we've built all these Copilots with one common architectural stack. We want to make that available so that everyone here can build their own Copilot for their applications. We will have everything from the AI infrastructure to the foundation models to the AI orchestration.
So one of the things that we did that greatly affected our ability to get these copilots out to market at scale and to do more ambitious things was to decide that inside of Microsoft, we are going to have one orchestration mechanism that we will use to help build our apps. That is called Semantic Kernel, which we've open sourced.
All right, so far I have not even mentioned the title of the talk, right? Semantic Kernel. So Semantic Kernel open source project really encapsulates all these sort of best practices that we learned inside of Microsoft building first-party copilots and now open source to allow enterprises, developers to hopefully come alongside with us on that journey too. So Semantic Kernel, in one statement, it's a lightweight open source orchestration SDK that lets you integrate large language models with native code in languages such as C#, Python, and Java. I think I want to emphasize the lightweight portion of it, and you'll see, or I'll talk about it in the kind of higher level architecture, but we want it to be something that is very easy to deploy, especially when you're talking about bringing something to production, and not a framework that doesn't have too much baggage, or at least all this extra stuff with it. I think it's important for that type of scenario. So fully open source, we have a community, growing community that you can all contribute to, join on Discord. I host pretty regular office hours as well. So if you want to drop by, say hi, talk about your use case, or talk about your challenges, happy to talk there. So in one picture also, right, the semantic kernel is ultimately addressed to app developers. And Microsoft is all about empowering not only the experts, right, the data scientists, the ML researchers of the world, but also really just the hobbyists or the people whose job it is to build an enterprise application. And for many of those people, they haven't been able to participate as much in AI, or at least have the frameworks to interact with these things. So that's why for the semantic kernel, we've taken this opinionated approach of how to build a AI orchestration framework that developers can choose to bring into their toolkits. So, for this, at the top level, if you remember from the picture of the Copilot stack, right? It's the AI user experience, whether it be a chatbot, whether it be something else, right? That is a separate conversation. I invite you to check out my colleague John Maeda, and VP of AI and design. He's much more equipped to talk about that piece. But in this middle, right, this is where the heart of the kernel is, and you'll see, as you all heard earlier the last couple days, bringing memory and bringing state into your applications is enabled by things like vector databases, even traditional data stores as well, but doing that in a more intelligent way. If you want to start bringing other tools, though, other connectors, having your application interact with the outside world, well, this is where this notion of plugins it really comes in. And imagine, right, being able to, I don't know, interact with Klarna or Instacart, and you just want to have that kind of magical experience where your chatbot or whatever can kind of use these tools, use these APIs to bring a differentiated experience to your application. Right here at the center of it is this notion of planning, and I'll actually talk about this for this latter half of the talk. But planning is really, I think, the magic unlock that AI has demonstrated, right? GPT-4 really showed off, in particular, its reasoning capabilities to be able to take a user's intent or user's ask or question, right, and be able to kind of express it or show off the steps needed to complete that goal or that ask. So we call that planning, it's wrapped into these abstractions called planners, of which there are multiple versions of. And all this is built on top of foundation models. And yes, while Microsoft and OpenAI are very tied at the hip, we also support the open source models that are out there. So if you have a model on Hugging Face, or if you've built your own and you just want to host it beyond some endpoint, you could bring that to the semantic kernel very easily. And in terms of the full dev cycle, which again, super important if you're going to be talking about rolling something out into production, things like telemetry and just overall dev tools, we have that as well. But again, that's a subject for another talk. But all this, hopefully, right, if you see this big picture, it's meant to empower the AI app developer. Okay, so let's dive a little bit into it. So it all begins with the user ask, And that ask comes into the kernel, which, again, super lightweight. And the kernel is meant to be like, OK, I'm taking this ask, and I'm either going to run a deterministic workflow that you've defined, a mix of native and semantic functions, or I'm going to have AI do this, this planning. So yes, I will take this plan and generate a step-by-step kind of roadmap, a blueprint for how to solve it. And that is based off of the skills or the plugins that you provide. That plan will then list off the set of functions to call, and you can choose whether or not to accept it and say, let's go, let's run with it, or you can go back and edit it if you so see fit. And I think that's a big point to call out because, at least for now, I'm a firm believer that human in the loop is still super important. And especially if you want to build trust in your AI applications, right? Having a plan that's transparent, plus being able to modify it as you see fit, provide additional feedback is core for any application. So to put it in a different view, right, starts with a user ask. That ask goes into the kernel. The kernel will take its skills that it has available to it and starts creating a plan. And that, in addition, also brings in external context. So these are the connectors I was talking about, where let's say you have the Microsoft Graph and you wanted to know about your entire enterprise work profile. Well, those connectors can come in as a plugin if you see fit. And even external data sources, external APIs. And with that, right, the kernel will do this orchestration for you to ultimately create that plan and allow you to run it in a pipeline. And that pipeline can be expressed, again, as something that you want to run over and over again. And there's, I think, some really interesting ideas about caching of plans or making them reusable. Or if you just want to have a more determinist or creative kind of expression of help me do research, right? Or help me, I don't know, plan for my date, right? You can have the kernel kind of take multiple different paths to arrive at some answer. Okay, so why build with a semantic kernel? Ultimately, right, you want to, especially in this world that we're in, where things are moving so quickly and it's just very hard to keep track of it all, you want to go from just showing off a cool demo to really putting something in production, right? You don't want to be in this world where you're just shipping one-off features that you end up having to rewrite code again and again for. So it is part of, the semantic kernel is part of this paved path for future large language, future applications built on top of large language models. And yeah, it helps you mix in the code that you've already written, right? If you already have all this expertise writing native code, then that's something that you should bring back into your application, right? And combine that with prompts, combine that with semantic functions, and yeah, just allow you to pursue scenarios that you were not able to do before. Okay, so let's talk planning. All right, so there was this paper or blog post written by Lillian Wang from OpenAI called LLM-powered autonomous agents. And agents is actually another kind of important term that is effectively, in summary, kind of combining tool use, planning, actions, and if you're ambitious enough, incorporating memory as well. So this was, I think, a good kind of one picture of what this concept looks like. And a big part of that is about planning. So in semantic kernel today, we at least expose 3 main planners. The first one is called an action planner. And the idea is that its main job is to take whatever the user ask is and just provide the one function or skill that you've imported to the kernel that best matches that goal. So if you're saying you want to do some addition, right, and you have a math skill, then the action planner will just identify that one particular skill as the right one to use. The other one is about sequential planning, and this is where you have maybe a more open-ended or multi-step ask, and you're having the planner stitch together multiple skills to run in a sequence from start to finish. So, and I'll show this off very shortly. This last one, that's probably even more magical and even more sometimes concerning, is a stepwise planner that can actually like reflect on itself, make observations, take action, and even correct itself if it's made mistakes. So let's just talk through a demo. This is the notebook that we have on our GitHub repo, so just walking through it. But so again, all begins with this ask. So in this case, the ask is, tomorrow's Valentine's Day. I need to come up with a few date ideas. My partner speaks French, so write it in French. Then convert it to the text to uppercase. So you can see all these little steps that I've very explicitly defined and be like, okay, kernel, help orchestrate to do that. So in order to do that, you provide the kernel with some skills. In this case, there's a summarize skill, a writer skill, a text skill, and each of those skills underneath it have separate functions that can each have their own prompts, but these are the top level things that are imported to the kernel. So in a basic planning scenario, this is one that, like, okay, let's create a JSON-based plan that will aim to take that ask and solve it sequentially. So this one in particular, this is the Python version, and the basic planner, more or less, you could think of it like a sequential planner as well, but this one's JSON-based, whereas the sequential one is XML-based. Those are just implementation details. But you can see right here, when I printed out the plan, like that's what it looks like. It takes this input, Valentine's date ideas, and it has these several subtasks and functions to call, and each output of a particular function becomes the input of the following function to call, and just running this in a sequence. So if you wanted to do a little bit more complexity and you wanted to introduce some more skills, right? Okay, now rewrite, let's create a new semantic skill, which again, you could just do this very simply in a prompt and a one-line function creation to rewrite the above in the style of Shakespeare, right? So just let's modify the ask and run the plan again, and you can see that the generated plan is now updated to reflect that. And now when you execute the plan, so the plan creation and plan execution step they're separate. They're two distinct things, and I think that's by design. You want to be able to review the plan. You want to be able to inspect it before you actually run it, and running it can be an expensive multi-call to the LLM. So in this case, that's what it created. I don't speak French, so hopefully this is okay. Okay, so I talked about sequential planning. This actual sequential planner, contrast to the basic planner in Python, is XML-based, but it's more or less the same concept. Okay, so action planner, as I brought up earlier, right? Its goal is to just identify the single function that is appropriate to do the task. So again, if the ask is what is the sum of 110 and 990, right? It will identify, okay, among all these skills that I have, and I printed it out, there's like a lowercase function, a trim function, an uppercase function, and there's more as well. There's the math skill at the very top. Hopefully, right, if it does the job correctly, it should just identify the proper function to call. And in this case, it does, because it gives the right result. I always have to double check with math, but looks right. And I think this is super important, at least, right, in the case of math or in the case of something that you need to have more, I want to call it guarantees, but it's non-deterministic, right? You want to have more control. And that's really the core of what we've heard enterprises really care about, is give us the tools that give us more control over these powerful but sometimes unruly LLMs. Okay, so spend a little bit more time on this one. Stepwise Planner, again, it's based off this MRKL, Modular Reasoning, Knowledge and Language, or REACT, Reasoning and Acting in Language Models, where you make, where the AI is able to form thoughts, observations, and take steps, and even fail to ultimately achieve the user's goal. So in this case, I won't go line by line, but this is basically, I added a quick like web search skill, allow it to search, in this case, Bing. And I added a few more skills like time and math. And now the planner is like, okay, let's take this ask, which I wrote down here as how many total championships combined the top 5 teams in the NBA have. And it's going to run. So it gives this result, but there's one thing about just taking a result and looking at it at face value, but let's look at the actual steps, because I think it's more illuminating to see what's happening behind the scenes. So if you look at it, and I highlighted these different pieces, in order to solve this ask that I gave it, the kernel is making different, the stepwise planner is making different thoughts. It's taking some actions, like, okay, I'm going to search with this particular query, and then I'm going to get those results back, and then synthesize it, right? And then formulate some new thoughts about that, and take any further action that I need to. So this was just step 0, but fast forward it even more, and you get to see like, okay, I found these things. Did I collect enough information? Like at least the planner would say, I think so. So now I'm just going to go add this all up, right? Use the math function to do that. But and this is where we talk about some of the challenges. Like, what's the answer for this question? Well, I'll grant that maybe top 5 teams can be ambiguous, the ask. So that's actually a big key principle of the semantic kernel is you want to ask smart to get smart, right? You want to make sure that whatever you're providing to the large language model is as explicit as you can be, because otherwise it can either make something up or go off in directions that you don't intend. But the actual answer is 52 championships. I had to make sure I added this up myself. So all this to say is that, and I was using GPT 3.5 Turbo to run this stepwise planning, but there's a long way to go. And even, I literally took the screenshot of what the Bing chat responded, and it returned 42. So it's nothing's perfect here. We're all still learning, and many open challenges remain. So I think we all are on this journey that really just kicked off, like a year ago, and at least in the mainstream, right? And we're all just trying to figure this out together. So as part of that, right, if you want to join this community, definitely invite you to join our Discord. Love to have you there. A lot of great conversations are happening of real developers trying to build these things. I guess plug for my own YouTube channels where I've been posting a lot of the semantic kernel content. So if you want to dive deeper into some of these topics, I even talked with Weaviate not too long ago. So it's a place for more content. Last, obviously, if you want to connect, happy to do so. You can find me on LinkedIn, YouTube, Twitter, and whatnot. And one more thing, shout out to Microsoft for Startups. They are out there in the booth. So if you're building a startup and you'd like to have Microsoft, and you'd like to have some help, go to the booth to talk to them. Okay, I literally have 4 seconds left. So thank you, everyone, for listening. Hopefully it was clear, but feel free to reach out. And I'll be upstairs.